Hello everyone, I'm Sumit Singhal, Associate Technical Architect with Systango.
And I'm Sparsh Piple, Senior Software Developer at Systango.
Today we'll be talking about serverless, one of the hot cloud computing trends, and it has become already more than a buzzword in the world of software architectures. All the big cloud vendors like Amazon, Microsoft and Google, they're investing heavily in serverless architectures today. So let's take a look at what serverless is.
Serverless architecture refers to services which eliminates the need for maintaining services. That is the basic definition of serverless, but what it means in the world of cloud computing. All the cloud providers offer serverless architecture as a functions. When we talk about function as a service or FaaS, it is a cloud offering that enables you to develop applications and deploy functionalities without maintaining a server.
Right. So we understand what serverless is. We have seen the basic definition. Now let's take a look at the characteristics of function as a service. First of all, abstraction. It provides complete abstraction of servers away from the developers. All the developers need to take care about is their business logic. They don't need to take care of any of the deployment of infrastructures. Next, event driven. These services are event driven. The functions execute only when an event occurs. As soon as the event is captured by the API gateway, the function will execute, complete the request, and probably go down. Next, scalability. These functions scale horizontally instantaneously. You don't have to worry about any of the server management or configuring the load balancers. Let's take a look at how these functions execute. What is the flow of a function execution? So as we see in the diagram, first of all we have on the left event sources. The event source could be a web application, a mobile application, or even the IoT devices. When an event is triggered, there are some rules configured for that event, and based on those rules, a function would be started by the container service. Now, at any point of time, there could be multiple instances of a function running. That depends on the load at that point of time. Now, this function can then in turn access different third-party or database services, maybe a database, maybe an analytics, or maybe a business intelligence service. As soon as the function completes the execution, it will return the response and then go down.
So we have seen what the functions are. Now let's understand its life cycle. A typical function as a service life cycle consists 5 steps. First of all, an event gets triggered to call the function. Secondly, it will find a warm container. Here, warm container is a container that previously serviced a request to the same function and kept loaded to handle another request. If there is no warm container available to serve the request, it will cold start a new one. The cold start means that the function will go through the entire startup process, which might take a while. After that, function processes the request and return the output. At last, container waits for a while that it can serve any other request that are coming at that time.
Right. Now we have seen what serverless is, what is the flow of execution, and even the life cycle of a function. But the bigger question is why serverless? Why would someone, an architect or a developer or even a business person choose serverless or function as a service? Let's take a look at the features or the advantages offered by serverless. First of all, scaling. We talked about how serverless scales horizontally. But what does that mean for the business? So Sparsh, do you remember the good old days when we had to put in a lot of manual efforts for scaling our applications?
Yes, I remember all the data center management that was needed. We had to procure a new hardware, configure it for our environment, deploy that hardware into our infrastructure just to make it ready for our application. Then come the process of bringing that server into the application infrastructure, configuring the load balancer and deploying the application. This process could take even days, and it was a cost nightmare to maintain the server if your load has goes down. Imagine a situation where you have to handle a very high amount of load just for a week and go back to your average load. How do you justify the cost of those servers?
Right. Now serverless comes to the rescue here. It scales automatically without any manual effort or even a configuration required. All you have to do is configure the API gateway. And to answer the situation which you mentioned, serverless can scale up and even scale down based on a load at any point of time. and you don't need to intervene in any manner, or even your DevOps team, right? Now next, another very important feature is self-management. Managing your own servers can bring in a lot of pain. And apart from scaling, which we talked about, there could be server upgrades, hardware crashes, network management, or even software patches that you need to do on your servers. The serverless or function as a service eliminates all these. The cloud provider which you choose will do all of these for you. And you can be rest assured that your service will always be up and running and will always be running the greatest or latest.
Now let's talk about the cost of serverless functions. Functions allows you to pay only for their amount of use, so it is based on pay-as-you-go model. If we compare it with some of the other offerings like platform as a service or infrastructure as a service, they charge a specific fee for the time you kept the resource with you. But with functions, you don't hold any resource, so you don't have to pay anything until you actually use them. The charges are based on the number of times the function is executed and the resources it takes during that execution time. After that, another feature comes, that is event driven. Nothing is in execution until there is an event. As soon as the event occurs, the function will start executing. The event could be an HTTP request or a scheduler, and when the execution finishes, the function instance goes down. Another feature is monitoring. So another job with your own infrastructure is setting up monitoring and alerting tools. You need to identify appropriate tools, set them up and configure as per your needs. Guess what? Function as a service comes with all these inside the box. As soon as you deploy your functions, the monitoring is set up along with them, making the life a bit easier for the operations guys.
Right. So we see a lot of advantages are there with serverless. But does that mean serverless is the silver bullet? Well, with every technologies there are some downsides and there are some limitations, and so does with serverless or function as a service. So let's talk about the limitations of serverless. First of all, vendor lock-in. So you're restricted by the features provided by the vendor. There could be a variety of limitations like the OS they support, the versions they support of different languages or different SDKs, and even the execution time. For example, if we talk about AWS Lambda, as of this point, Lambda supports Node.js 8 as the latest version, whereas Node.js 10 has arrived from quite along. Another limitation I can remember with Lambda is an execution limit of 15 minutes. So if you have a task which takes more than 15 minutes, you're bound there and you cannot use AWS Lambda. Now, we talked about pay-as-you-go model. Now, that certainly is a benefit, but that can also be a limitation. If we talk about long run, if costs are driven entirely by the usage, it could be very unpredictable. Also, if you compare the functions which are executed quite frequently, like maybe a few calls per second, now in that case, platform as a service could potentially cost you less as compared to Lambda.
And what about the performance? Especially when there is a cold start involved.
Right. Now, functions performance depends heavily on two things: the frequency of the cold starts and the performance of your code itself. Now, cold start is something you cannot control very much, and it could be a real killer if the response time is a critical factor for you. Now, cold starts, apart from cold starts, as we talked about the performance of your code. Now, the overall performance of the function is limited by your code only. You cannot optimize anything on the hardware or even on the OS level. So Lambda seems good when you can ignore the cold start and probably are not worried about the response times. Now, security. What about security?
So you brought a very critical point here. Although the cloud vendors provide the best of security and try to keep up with it, there could be some areas where you might feel restricted. There could be additional security measures you would need in your infrastructure, but you cannot alter anything. For example, there could be patches which you need ASAP, but blocked by vendor cycle.
Right. So I think that covers all the important or the most important limitations which serverless has, and I think we have covered all the aspects of serverless, their advantages, their function lifecycle, execution flow, and everything. But where can you use serverless? Let's take a look at the use cases where they best fit. So serverless works best when the frequency is low, the frequency of events is low, and a little delay in response time is acceptable. For example, there could be batch processes or like report generation APIs. So there you can afford a little delay in the response times. Another good use case I can think of is sending notifications like emails, SMSs, and even push notifications. So usually you don't need critical response times in those kind of use cases. I think that covers all for today, and we hope that we have provided impactful information on serverless and where you can use that. And we thank you for your time.